Hey everyone, and welcome back to The Explainer. I am super excited you're here today because we're diving into a massive technological shift. Seriously, this is actively transforming the roads we drive on every single day. Today, we're driving into the future and demystifying the wild, incredible world of connected vehicles.
Just think about it for a second. What if cars could actually talk to each other? I know. It sounds kind of like something straight out of a sci-fi movie, right? But when you think about the high stakes of road safety, the daily nightmare of traffic congestion, and just the sheer number of unpredictable things drivers deal with, well, what if a vehicle could instantly warn the cars around it about some invisible hazard up ahead? That's the exact premise of the tech we're unpacking today.
So here's our roadmap for today's explainer. First, the connected vehicle revolution. Second, V2V, cars talking to cars. Third, V2X, connecting to everything. Fourth, the hardware behind the magic. Fifth, big benefits for everyone. And finally, number 6, the future of smart roads. All right, let's jump right in.
Section 1. The connected vehicle revolution, more than just a self-driving car.
Okay, so this revolution, it's already quietly happening right in our own garages. Out of roughly 290 million vehicles on the road in the US, about 84 million of them are already connected. And get this, with 75% of new vehicles sold recently including embedded connectivity, this thing is scaling up massively. But what does that actually mean? Well, let's ground ourselves in the core definition. A connected vehicle is basically any vehicle capable of sending, receiving, and processing digital data to communicate with other systems. It starts with an internet connection, sure, but modern connected fleets use onboard sensors, software, and communication tech to constantly swap data about their location, speed, engine health, and what's going on around them.
Now here's a really crucial distinction, because honestly, people mix these two terms up all the time. Connected vehicles are entirely about communication and data exchange. They're just constantly sharing info to help a human driver or maybe a fleet manager make better decisions. Autonomous vehicles, on the other hand, they're designed to actually do the driving with little to zero human input. So simply put, connectivity is the communication and automation is the action.
So how does this two-way data stream actually happen behind the scenes? Well, it generally comes down to two methods. You've got embedded connectivity, which means the vehicle rolls right off the factory floor with built-in modems and SIM cards hardwired directly to the internet. Then you've got tethered connectivity. That relies on an external device, like syncing up your smartphone or plugging in an aftermarket telematics unit. And that second option is actually incredibly useful for bringing older, legacy vehicles into this brand new connected network.
Moving on to Section 2, V2V, cars talking to cars, the first circle of connectivity.
Picture this. You're cruising down the highway. Suddenly, for step 1, the car in front of you just slams on its brakes. Its sensors detect this instantly. In step 2, that vehicle's onboard communication unit immediately fires off what's called a basic safety message, or BSM, which beams out its speed, its position, and the fact that it's braking hard. Then, step 3, the car right behind it receives that message, and its internal computer automatically triggers a huge alert, or maybe even activates emergency braking before the human driver even has time to react.
Now, get a load of this number. Less than 20 milliseconds. That is the latency, the delay for transmitting these basic safety messages. Just to put that into perspective, blinking your eye takes about 100 to 400 milliseconds. So literally in less time than it takes for you to blink, these cars have talked to each other, processed the danger, and initiated a safety response. That staggering speed is absolutely the difference between a close call and a catastrophic collision.
Section 3, V2X, connecting to everything, decoding the alphabet soup.
Okay, I promised earlier we decode the alphabet soup, so here is your master key. V2I stands for Vehicle to Infrastructure. V2N is Vehicle to Network, basically using cellular systems for things like traffic updates. V2P is Vehicle to Pedestrian. V2G is Vehicle to Grid, which is super cool. It allows electric vehicles to actually send stored energy back to the power grid when demand is high. And finally, V2C is Vehicle to Cloud, which handles stuff like over-the-air software updates. Honestly, I know it sounds like a bunch of droid names from Star Wars, but it really just describes exactly what your car is talking to out there.
Let's look at a concrete example of V2I in the real world. Imagine you're driving up to a busy intersection and the traffic signal literally broadcasts an advanced warning right to your dashboard that the light is about to turn red. Or maybe there's a smart work zone sign that pings your car about a lane closure a whole mile ahead. This tech lets traffic flow so much more smoothly because it gives drivers time to adjust their speed naturally rather than doing that awful last-second brake slam we all hate. Then there's V2P, vehicle to pedestrian, which is absolutely vital for protecting vulnerable people on the street. Let's say it's pouring rain at night, visibility is practically zero. A pedestrian is walking near an intersection. With this tech, their smartphone acts like a digital beacon, broadcasting their exact position. If they unexpectedly step into the crosswalk, the cars nearby get an immediate alert, allowing the driver or the car's automated brakes to stop safely before tragedy strikes.
Section 4. Hardware behind the magic. The tech making communication possible.
So what is actually powering all this invisible data? Here's the hardware stack. First up, onboard communication units, or OBUs. These act as the brain. They communicate using either DSRC, that's dedicated short-range communications, running on the 5.9 GHz spectrum for super-fast, close-range chats up to 300 meters, or they use cellular V2X, which taps into those broader 4G and 5G networks we already use. Add to that the car's sensory eyes, things like radar, LiDAR, and high-def cameras, all of it anchored by ultra-precise GPS, so the car knows exactly where everything is in space.
Section 5. Big benefits for everyone. Why this technology matters.
I really want this next number to sink in. 79%. Based on the research in our sources, studies suggest that an unbelievable 79% of crashes could be prevented using these vehicle-to-vehicle systems. Just think about that. By giving us those split-second blind spot detections, intersection warnings, and collision alerts, this technology literally has the potential to save countless lives. It's a total game changer.
But the benefits extend way, way beyond just safety. Take cooperative adaptive cruise control, where vehicles talk to each other to synchronize their speeds. That drastically cuts down on that annoying stop-and-go congestion. Plus, fleet operators are seeing way lower maintenance costs because the vehicles diagnose themselves and report issues before a full-blown breakdown even happens. You get real-time data for better routing to avoid traffic jams, and ultimately, smoother, more efficient driving means we're burning less fuel and pumping way fewer CO2 emissions into the environment.
There's a quote from our sources that I think just perfectly hits the nail on the head regarding fleet management. Connected systems can provide hazard notifications, driver coaching, and safety insights that help prevent incidents. What we're witnessing here is a huge, fundamental shift from reactive management, dealing with a crash or a broken engine after the fact, to proactive operations where you literally stop the problem before it ever has a chance to happen.
Section 6. The future of smart roads. What's next for connected mobility?
Looking just a little bit ahead, we're going to see fully interconnected networks where V2X, the cellular networks, and the cloud all act as one giant seamless brain. And one of the most fascinating applications coming out of this is called platooning. Imagine 2 or 3 massive transport trucks on the highway traveling super close together in a caravan. Because they're connected, they synchronize their braking and accelerating perfectly. That severely cuts down on aerodynamic drag, which ends up saving a massive amount of fuel and lowering emissions on long hauls, all while coordinating directly with smart city traffic grids.
And the technology actually transmitting all this data is evolving too. Enter Li-Fi. This is an amazing emerging alternative to traditional radio waves. Li-Fi actually uses invisible light waves for super fast, highly secure data transmission with incredibly low interference. Because it can just piggyback on existing lighting systems like LED streetlights or even your car's headlights, it offers this highly efficient, hyper-fast way for cars to share data while they're on the move.
Which brings us to our final thought for today. As our cars learn to seamlessly communicate with everything around them, other vehicles, pedestrians, the traffic lights, the cloud itself, what is your morning commute going to look like in 10 years? Will we even need traffic lights? Are accidents going to become a thing of the past? This connected vehicle revolution isn't just about throwing a Wi-Fi router into a dashboard. It is about fundamentally redesigning the safety and efficiency of how humanity moves. Thank you so much for joining me on this explainer today. Keep learning, stay curious, and I'll see you next time.